Well, it is 3:30, so I think we'll get started with our panel discussion. This is 3D Printing 101. So we're really excited to talk with you all about our love of 3D printing. About our love of 3D printing, and we hope to give you some ideas on how and where to start. I've calculated it. We have 29 years of experience combined in 3D printing. So let's go down the line and have the panelists introduce themselves with their name, pronouns, and what you like to make with 3D printing. And we'll start. I'm Neal, I'm the moderator, and I like to make some different types of art of my own design. Lots of kind of bodies and faces and that kind of stuff, so it's really great for that kind of application. Nick, yeah.
Hi, I'm Nick Glover. My pronouns are he, him. I do a lot of theater and comedy, so I end up printing a lot of silly things for comedy purposes. I've probably printed over 700 dicks with my printers. And for comedic purposes only. And but then I feel like it's kind of like every problem looks like a nail when your only tool is a hammer situation. So every problem in our home gets fixed with 3D printing. That door doesn't open right, I will 3D print our way out of that problem for us.
I am Jeff Winsor, he, him, and I just finished my third year at a local high school, kind of running their 3D printers. So I've printed a whole lot of very poorly designed things. And then personally, props for costumes, and then fixing things around the house.
And I'm Todd Murray. Is my microphone on? Hi, I'm Todd Murray, he, him. I've been doing costuming since about 2007 or so. I got the 3D printer in 2016, and this is my first project, Dr. Doom. So some parts of this are Warbler with 3D printed accents, and some pieces are entirely 3D printed. I'd be happy to entertain any questions afterward. But I mainly do 3D printing for costumes.
Hello, my name is on. Okay. Hello, my name is Andrea Herman. I'm the Innovation Lab Coordinator at St. Paul Public Library. That's our makerspace. I've been teaching 3D printing and 3D design classes for a while, and I like making practical stuff and also fun stuff. I've been into miniatures a lot lately.
Awesome. I also forgot to say my pronouns. I use they or he pronouns.
She, her.
I think the first question is kind of where do you go to get started? If you want to try out 3D printing, what are some resources either in town or ways that you can kind of give it a go? Andrea, I had this in your mind.
So at the George Latimer Central Library, we have an Innovation Lab makerspace where you can join for free. You just have to do a little orientation, and then you can use our 3D printers for 4 hours per week. And we do not currently charge for filament.
Nice.
How I did my start was a friend that has a lot more experience who was asking about getting into the hobby said every once in a while Micro Center will sell an Ender 3 Pro for $100. It is a very low risk investment to try to get into the hobby, and it's a very quick way to find out what you do and don't like about a printer for buying a better printer, or if you're real into the mechanics and the tinkering, it's a printer that is infinitely upgradable and expandable with a lot of people that have the same printer who have put in that time and resources. So I don't know, like Adam Savage's book where he talks about trying out a new tool, his advice is buy the cheapest, shittiest one right off the bat, wear it out, figure out what you like and don't like about it. Maybe the cheap one is all you need, or maybe you want to go buy a Cadillac version. But that printer at that price point is a very accessible way to get into the hobby.
What's it called?
The Ender 3 Pro, E-N-D-E-R.
Yeah, I started with an Ender 3 way back in the day, and you're absolutely right, Nick. It's one that you should get if you like to tinker, especially because I had to repair that thing so many times. now I feel like I can repair anything on the printer because I owned that for a few years.
Yeah, I bought my nephew an Ender 3 for his 16th birthday. He's now in college and studying industrial design, so I think I kind of spurred him on that fact.
Oh, yeah.
As far as my personal printer, I've got a Flash Forge Creator. Bought that. It's kind of a MakerBot clone, so it's somewhat older, but it's been a real workhorse for me.
As a heads up, the Ender 3 is similar to some car brands that have been around, like the Ford F-150, where you can have an Ender 3 and it is years separated and nothing alike to a new Ender 3. They have like 6 different versions of Ender 3 that you can buy right now.
Well, I think
There isn't a Ford Chevy rivalry in 3D printers. I'm like, you know, you get the Ford Chevy rivalry, the thing's pissing at each other.
Oh, yeah. Tribalism, right? Everywhere.
right, yeah. Bamboo versus Prusa.
That's
So, on the topic of affordability and reliability, can you have both in a printer? That's a good question, right?
So, like my advice, I bought an Ender 3 Pro, and right away it was like, I learned a lot, right? It was like, I know how to tinker now, I know how to tune, and then I promptly went out and bought a printer that doesn't require much tinkering or tuning, despite enjoying that part of it. But I did spend a lot of money on a Prusa XL, and their printers are very expensive and very reliable, and I am very privileged to be able to go that route. And so I don't have a lot of experience in between those marks, but I will say, like, I spent more money to get a very reliable printer that has never failed me except for when I did something kind of dumb or less optimally.
Yeah, in our lab we have a Lowell Spot, and which was $12.50, and Ultimaker S3, which was $38.50. So it's a little higher. We have some Prusas in our teen area. I believe you can get one cheaper if you put it together yourself. I personally wouldn't get any printer that didn't have good tech support, so most of the Chinese ones, I think.
Actually, my first printer was a printer bot that I bought from Micro Center. And I bought one, and one of the pieces failed. I think it was the leveling detector. So I returned that to Micro Center, got another one. That failed somehow, so I got a third one. It lost its firmware, just kind of had brain damage, so I returned it, swore off printer bot. I don't think they're running anymore.
Those BL Touch ones or whatever, the sensor?
Yeah.
Yeah, and right now I'm printing on a Reality K1 Max, which is, you know, as far as kind of the cheaper line of big volume printers go, it's pretty reliable. It's kind of a sort of a Chinese knockoff clone of a really nice printer called the Bamboo brand. But you know, it's certainly something that I've had to unclog numerous times, and I've replaced the nozzle already. So it's still one you have to tinker with, but you still kind of get the kind of.
There are people there's a pretty healthy secondhand market for like Prusa printers, where if you're looking to get in the hobby and you want that like brand name reliability, they're like the BMW of printers, I like to say, right? And like if you want that brand or that reliability, people are still selling like the M3 Prusas for a fair amount of money, but you can get, you know, that type of a printer secondhand because someone's upgrading their farm or whatever. I know Bamboo has the whole spectrum of, like, they have intro printers, like their mini is not, I think it's like $250 or $300 or something like that. And then they obviously go as much as you want to spend up from there, more or less. And a lot of people swear by that brand. I'm not terribly familiar personally.
Yeah, I've heard a lot of good things about Bamboo.
The one negative maybe about them, I think I've heard, is that they're like partially sponsored by the government of China. So like, maybe don't put it on your network. But like, if you want an inexpensive printer that just works, the A1 Mini I think is a great option. I've had a Prusa Mini that hundreds of hours and not many issues. And I think another knock on Bamboo is they don't make them user serviceable that much. whereas Prusa or Creality, you can pretty much buy any of the parts that you need.
I think every single part on a Prusa printer has like a little QR code on it that links you to their documentation on how to service and replace that item and buy a replacement part from them. Just about every part, which is pretty amazing. I think it's worth noting that all of these printers are standing on the shoulders of giants. There's a lot of open source at the base of 3D printing where, like Prusa is building their slicer software and their printer design off of other people's designs and so on and so forth. And so like you see a lot of similarities and you hear people talk about, oh, it's a this clone or a that clone. And that's because a lot of these designs are open in a way where anyone can jump in and kind of grab one of those designs and make their own brand or version of it with a lot of improvements. So even like the nozzles on most printers are pretty universal and swappable with some exceptions of Prusa's later printers and Bamboo's printers. Most of them use kind of the same stuff, which you can get at Micro Center, which is super handy.
It's great having a Micro Center down the road.
Micro Center doesn't carry a lot of the Prusa parts.
No.
They carry Creality and Bamboo, and maybe a couple other ones, but yeah, they don't have Prusa stuff.
It's the biggest downside with Prusa, which is relevant to the cost discussion, is Prusa operates in Czechoslovakia, and almost everything ships from, or Czech Republic, excuse me, almost everything ships from there. So you're paying more for shipping, it's taking longer to get here. There are a couple of American companies that buy in bulk and sell and distribute domestically, but even then, like, you're paying for those shipping costs that they paid to get the stuff there. So like, I can't, if I have a nozzle that breaks, unless I'm using an adapter, I can't just pop over to the store and get a new nozzle. I need to like buy spare parts in advance of things breaking so that I don't get my projects interrupted.
Printed Solid is Prusa's American distributor.
That's
So let's also talk about some applications of 3D printing. Obviously we can do a lot with costuming, household goods. What are some other things that people might not think about that you can make with a printer?
when I'm deciding a product to buy, this version of that, or not printers, consumer products, I will often go to sites where you can find 3D designs like Printables or Thingiverse and look up that device and that model number to see if other people have designed things for it and how often it shows up there, so that I know how I might improve the thing I'm buying, right? Like if I'm picking a fan for my house, I might want to buy a fan that I know someone has designed a replaceable feet for, or the whole fan blade setup, or the fan, grid housing or whatever, right? Like I might be willing to spend $5 more on brand B instead of brand A, just knowing that other people have already done all the measuring on that devices, to the point where even if I don't want to use their parts, I can download their designs and tinker them to suit my needs, knowing that they already took those measurements and figured out that it works on those devices. And so like, it has influenced everything I buy now. When I'm like even like looking at a new soundbar, I'm like, someone's got a remote holder for this, right? Yeah, okay, great. I can use that measurement for my own, couch console remote storage thing, right? Things like that where, print your way out of every problem.
They might not, like, if anybody's used McMaster-Carr for ordering parts and stuff, they have, most of their products have an STL available that you can just download and then 3D print to check the size and fit and stuff. And that has been super helpful. Hopefully they never take that feature away.
If people aren't familiar with that, can you explain what that is?
Yeah, so I coach high school robotics, and many of our parts and things we buy from McMaster-Carr, because they'll have any bolt that you need, any small hardware, stuff like that. They used to carry Swedish fish even. But yeah, so it's like a giant hardware store. Their website is fantastic. Their search feature is probably one of the best. But so if you need to check if I don't know, a holder for a fire extinguisher is the right size or whatever, you can just download the STL, probably.
Nice. See, I'm gonna fill into Andrea and Jeff. When you're designing your own prints, what kind of software do you use, or where do you start?
I am still using Tinkercad.
Yeah.
It's a classic for a reason. And it's got a lot of training. It has its own training material, since nowadays kids learn it in 7th grade, right? In middle school. And we also have something called, has anyone heard of LinkedIn Learning?
Yeah.
So if you register your card in St. Paul, you can get free tutorials. So if you want to learn Tinkercad, or if you want to learn Blender, Fusion 360, whatever, you can, they're really great online tutorials for that.
And you can get free LinkedIn Learning at the Hennepin County Library.
Yeah, a lot of different libraries, so check your local library.
For my costume here, I used SketchUp, which is kind of an older program. I think they're pretty much online now, but I've got the desktop client. It came with, well, they had a book at the time. I don't know if they still publish books on that or not. I've also experimented with Blender just a little bit, but it's kind of Byzantine to me. So, I've actually been looking for a better 3D modeling program, so hoping to hear some ideas here.
Yeah, I've been using Blender for about a year now and finding some success with it, but the big benefit of that one is that it's free and open source. So can't really beat the price.
Blender Fusion 360 is also free. There's more features if you pay for it. Onshape is what our robotics team uses, and that's free. If you're using the free version, your file is going to be publicly available and searchable, which is actually kind of nice because it's just another kind of printables thing where if you need a design, you can look in Onshape. Tinkercad is fantastic. It'll do most of what you need, probably. The maybe thing to watch out for is I've had students that would design something in Blender and in Onshape. If you design something that is infinitely thin, but it looks like it's there in the CAD model, when you go to print it, the printer sees a infinitely thin wall and says, "Oh, cool, I'm done. I finished it," so it just won't print. So before you actually go to print something you've designed, double check in in Prusa Slicer, you'll slice it and it'll show you what it thinks it's going to print. Double check that all the walls are there. Your wall needs to be at least as big as your nozzle, preferably twice as big, so you get 2 walls in there. The width of your nozzle matters because it's physically going to force a little noodle of plastic out that nozzle. And if your wall is less than the thickness of the nozzle, the printer's, it's done, it did it, we're good. And then it's going to move up and try and print in space. And good luck.
Won't some slicers tell you that, warn you?
Sometimes. A little bit.
Yeah.
I use Simplify 3D, and it's got some checks in there to make sure that your model is working. And also, I use a plugin with SketchUp that detects any anomalies in your model, like missing faces or reversed faces.
Sorry.
Yeah, go ahead.
My brother-in-law does 3D animation stuff, and so I've asked him to help me with designs and things in the past, and I've learned really quick that there's a big difference when you're looking at 3D modeling between artistic 3D models, which are usually hollow to save CPU and calculation, right? They only need to process the parts that you see visually. Everything else cannot be calculated to save, efficiency, versus engineering or architectural 3D design where that thickness and that density in the walls, like he's talking about, really matter. And so there are ways to work with them both and between them both and convert back and forth. But like if you're looking at these classes and things for online, maybe like kind of keep in mind, like, am I 3D designing something that is like more like a graphic or a video, or am I 3D designing something that is going to need to support 5 pounds of weight or this much torque, right? I use Tinkercad almost exclusively. You can do a fair amount of very simple modeling in your slicer by adding objects and text and negative volumes and things like that, but Tinkercad is so great because it's just basic geometry, and it's like, I want a square, great. Now I want to remove this triangle's worth of volume from that square here. You move it all around and you mesh them together, and it's like, great, now I have a square minus that triangle. Awesome. Import. Bring in an STL or a file that someone else did. Merge them together. Combine them. Export it. Boom. Now you have a little, whatever it is someone else's design is, but with the mount that you need for the thing that you designed. And like, even if you're just merging 2 models together, like, I have a Wise camera that I want to put on my printer to monitor my prints. This other person already engineered a mount for a different type of camera. Great, put them both into Tinkercad. Put one on top of the other. Merge, export, print, boom. Now I have a stand that holds my Wise camera on my printer to babysit it. Like, Tinkercad is so user accessible and so conceptually easy to jump into, I feel like. I am hesitant to learn new things, maybe even because of how well it suited me and how used to it I am.
Yeah, it is a really easy one to pick up. I think when I just was starting doing some 3D printing classes, I was recommended Tinkercad. I ended up designing a little Raspberry Pi case. It already has like a little model for a Raspberry Pi that you can kind of match everything up. So it's a really cool tool.
Oh, we haven't covered the difference between FDM and resin printers yet.
Oh yeah. We're all talking about that. FDM.
Yeah. Well, I haven't actually done any resin printing myself, but essentially, the kind of printers we've talked about are FDM, fiber deposition modeling, whereas it's got a filament that's about 1.75 millimeters and forces it through a little extruder, and the extruder moves around on the tabletop, or the tabletop moves and the extruder stays still. It's kind of like a hot melt glue gun that is very finely controlled. Resin printers they have a tank of resin, and the model is built up by flashing little UV LED laser pulses at it where the plastic is supposed to be deposed, and it builds it layer by layer. It lifts the plate out of the solution, whereas the FDM fiber deposition modeling kind of build up from the plate.
Resin printing it's also gotten a whole lot easier in the last few years. The main thing to watch out for resin printing is the resin itself is very dangerous to touch. So get good latex or rubber gloves, wear a respirator, and don't get it on your skin. But otherwise, you're just kind of building it up down from the top instead of up from the bottom. And in your slicer, you'll have to design or add drainage holes, because if you have a large solid thing, it's not going to print all of it solidly. Like for our printers, it's going to print infill, which immediately change your infill from grid to something else.
Pro tip.
Yeah, grid is trash. But in a resin printer, if you don't design or add in drainage holes, it'll just leave resin in there to like slosh around. It's captive. It's essentially safe, and if UV can get through, it'll solidify it. But don't be respectful of resin and watch out for it.
Do you need ventilation for resin?
Ideally, yes.
Yeah, that's why we don't have it, because the library doesn't have proper ventilation.
And there's certain advantages to the resin printer. If you're looking to print like miniatures for gaming or something like that, resin is a really great way to go.
Statues with detail in general.
The resolution on that is just so good. You can really find details. You're not going to get that as easily with an extrusion-based printer.
If you want kind of like a really quick, cheap, good example of the mechanics of resin printers, you may have seen those like glue pens that have a little UV light on the back end, where it's like a plastic pen is what they're called, where it's like, oh, fix your glasses with this plastic pen. What those are is a reservoir of resin that's UV cured, and you're kind of painting that onto the things you're repairing, and then you flip your pen around and it has a little UV LED on the end, and you're curing it with those UV lights. That's the same mechanical way that these resin printers work, is it's using UV lasers to hit this resin, which instantly cures and solidifies it. And because lasers are so damn precise, they can get a level of details that FDM printers can't. But those pens work on the same principle. And the resin used in these printers has applications outside of those 3D printing, where I see a lot of people that do FDM printing who will go buy the resin used for a 3D printer and paint it onto their models to fill in the gaps and to smooth out some of the lines. And then they'll put them in the same UV chamber to like cure them real quick and smooth and harden everything up. And then you end up with like a hard candy shell on the outside too, which is a little bit more ding resistant and less likely to chip. It's pretty great stuff. It's just, my wife is very smell sensitive, and it'll never have a place in our house.
Yeah, I am too. Don't some people also like it because they hate layer lines of the FDM? I'm like, since I'm not doing stuff like this, often the layer lines, you don't want them, that you're gonna get to FDM. So you painted this, right?
Well, what I did with this is I used this auto body filler. It's this one-part auto body filler called I want to say Evercoat, but I don't know if I got the name right. There's a version that Bondo makes as well. So what I did is if you ever built, I'm going to date myself here, but if you ever built a cabin out of Lincoln logs, you know the logs have this texture. Kind of want to avoid, your FDM prints are going to come out like that. You kind of want to avoid that if you're going to have something that you want to have as a costume. So with this, I filled it in. For some parts of it, I filled it in with one part body filler, and then sanded, and then filled again, and all that. I printed this out of ABS, so I used acetone with some ABS mixed into it as a way to smooth it as well.
The company Smooth On, you may have seen like Smooth On for like casting silicone and stuff like that. You can find their products at Dick Blick, or Blick is in Michael's, I think. They make a resin for smoothing FDM prints specifically called XTC 3D. I used it for the first time on a costume I had for this weekend, and I feel like I leveled up. Like I feel like the way I print costume stuff in the future is forever changed, because my first time using it, I felt happy enough with the results that I didn't need to like go back and sand and touch up and change things. And I feel like I can do it even better in the future having used it now. But it's basically just like a hardener, it's like a two-part resin that you paint on, and it just has really low surface tension, so it smooths and runs down really well and levels kind of automatically and cures pretty darn fast. And it has this very pleasant knock to it when you knock on the shell. But like the costume that I used it on is a big helmet thing, and I printed it in 4 different parts that I joined not perfectly to hide those join lines, and I used plastic wood filler for the most egregious parts, and then I used this resin over the top, and after airbrushing, you can't see a damn layer line on the thing. If you really look at where the joins are, you can find them, but like, it's very impressive, and I was very amateurish in my use of it, so I can't imagine with more practice it'll be even better results.
Yeah, another material that I've used to finish a print, particularly if I'm looking for like kind of a plaster effect or almost like a stucco, is golden sculpting medium or molding medium, and that's kind of a, it's an acrylic painting material that you would normally mix in with some other acrylic paint, but it actually has a really nice kind of finish to it. It's kind of soft to the touch, and if you do sand it, it kind of heats it up a little bit and really kind of smooths that out nicely.
Is it plastic? What is it?
It's a plastic. Yeah. Cool. It's the same material as acrylic paint, just a little thicker.
What's it called? Electrolyze, where you put something put metal on with water. Has anyone tried that?
Electroplating?
Electroplate. I have one of the lab members was going to electroplate a chess pieces.
I haven't done it, but I've seen videos of it. It's awesome.
That would be cool. So the water makes the metal adhere to your print.
I think you need to paint it with something that's reactive, and then you dip it into like a saltwater bath or whatever it is, and you run electricity through it while adding metal additives, and the electrical charge causes the metal particles to stick to it. If you've ever had like gold-plated plastic jewelry, it's the exact same process. And so people, like Andrea is saying, people have figured out how to run electroplating rigs at home for pretty easy and cheap to electroplate their 3D prints to get them to look like gold or bronze or silver or whatever. And it also has a bonus of smoothing things out a bit. I've only seen it done online. It looks fascinating and messy.
There's a material by Protopasta where they actually do metal infused PLA.
Yeah.
And I've played with the bronze version of that, and well, it absolutely destroys your nozzle. But and yeah, once you get it out, you can actually polish it and get kind of like a metallic sheen to it. It's expensive though. I think it was like $40 for a half a kilogram, which is a lot.
Has anyone done any food safe resins?
It just as a heads up, PETG is food safe, but because of the layer lines, don't like put water or other things in it because all those layer lines can get bacteria. You can post-process and cover it and do stuff. Like my buddy made a big mug, but even though it's food safe, don't use it as a fork or anything.
The plastic itself is food safe. PET is what water bottles are made out of. But the way you print and use it ends up being porous, which is inherently not food safe. Yeah. ABS and AESA are food safe if you smooth out the parts of them that are porous. I've done PETG that I've resin coated to make it food safe with a food safe coating. Like I think Mod Podge makes like dishwasher safe, food safe coatings for like doing mugs and stuff, and I think you can use that to food safe 3D prints as long as you do enough layers of it where that pitting and those little caverns in there are filled up adequately. I see a lot of things people design where I'm like, you designed a mug or something else that interfaces with your body in a way that might be more adult. You should not print that and use that with your body in any way because no material that you're printing it in will be safe. That said, you can 3D print molds for things and then cast them out of safe materials.
And PLA is 100% not food safe.
It is.
Without a resin coating.
Yes, it's bad news. And you don't really want to coat it to use it to make it food safe either because it's just not strong in that way.
Right.
How 101 are we getting? Like, do people understand when we say PLA and PETG?
Why don't you cover different types of materials?
Yeah. So the most common and cheapest and easiest available is called PLA. It's poly something acid.
Polylactic acid.
My recommendation, back to Micro Center, the month of November when they do their Black Friday deal, it's the whole month of November pretty much. You can buy refillable spools and get your kilogram of material down to like $10, $12. And PLA Plus is just slightly better. I'm not sure exactly what the difference is, but that's pretty much all that I run through my printers. Unless something is going outside in sunlight, then PETG or PETG has a higher melting point, which your printer needs to be a little hotter to print, but is also super easy to print and won't melt in your car as readily. And then there's they've kind of been phased out, ASA or some of the other filaments. ASA, when you print it, there's a slight smell to it, but that's another higher melting point thing that is still easy to print. If you want to print stuff that glows in the dark, get a hardened nozzle, or there's wood filament, which has wood particles in it. Anything that's not just PLA or PETG, you'll want to get a hardened nozzle because it's slightly abrasive, and the basic nozzle is brass, which is a very soft metal. So it'll, like your nozzle width is going to slowly get bigger. Rating.
Another one is TPU. So I actually print phone cases. This is so it's a nice flexible kind of rubbery material and really good for different things like that.
Yeah, TPU, another great one. Pay attention to the hardness on it. So like it's rated out of 100. 100 is pretty hard. 50 is really soft. I tend to stick around 90. But yeah, that's another great thing. It's harder to support it. So if you're designing something, make sure the bottom is flat, and that'll go on the print bed, and then go from there.
I think, like has been said, PLA is like so easy and cheap, and you can get it in such a variety of colors that it's probably good for like 95% of printing that's done, right? And the times you don't use PLA is when you have some sort of a mechanical need. So like if you need something that's more, PLA is very brittle because it's very hard, and it'll snap and it'll shatter if you put too much torque or different kinds of forces on it. Whereas PETG has a little bit of flex to it. It's better at higher temperatures. It's not going to melt in your car. You can hot glue it to things and not screw up a cosplay on a Tuesday night like I did. And so the more exotic you're getting with your materials, it's usually because you have some sort of a need, whether that's a mechanical need or food safety or a processing mechanical need, where it's like, you can't really sand PLA. Because the melting point is so low, if you're not careful when you sand it, it kind of like melts off into little gross clumps and it's really rough. But if you're wet sanding it, or you're using like a fine enough sandpaper, it works a little bit better. Whereas PETG sands a lot better, even though the melting point is only like 40 degrees Celsius hotter. I think something worth noting for a 101 thing is that nothing is going to get you more adapted to the metric system than the hobby of 3D printing, because everything is done in millimeters and centimeters, and all your temperatures are in Celsius and grams. You're measuring how much filament you're using, you're measuring it in meters and grams. And so like all of a sudden, when I'm looking at things and measuring them and eyeballing distances, I am using metric more and more and more the more I use this hobby. And so I feel like 3D printing is actually just a conspiracy to get Americans to learn the metric system.
It's big metric. It's big metric. I was also going to say PLA is compostable, if that's a concern. It's made out of cornstarch. That's why it's brittle, but.
At least in industrial composting,
Yeah.
it'll break down.
My wife was like, picked up some bits or some supports that I had kind of left behind in my excitement at one point and put them in the recycling bin. And I was like, actually, you can't recycle this plastic. And she's like, oh no, this is like a big chunk of plastic that we can't recycle. I'm like, no, don't worry, it'll biodegrade. And she's like, that doesn't seem sustainable for props and stuff. Like, so her concern changed all of a sudden to all the stuff I've been printing for theater and for comedy for us.
If you are printing all in in one material, you can collect all of it and grind it up, and then I would make a mold for like coasters or something, and that'll reduce your waste by a whole bunch.
Let's see.
Do any of you recycle filament in like a process it into new filament or have any experience with that madness?
No, I've looked into it, and I know there's a shop in the Burnsville Mall, I think, that has they don't exactly recycle it and like extrude it into printable filament, but they will melt it down into a sheet for you.
Oh,
So then you can use that to kind of construct something different.
that's super neat.
Yeah. Yeah.
Is it Maker's Den? Is that?
Yes, Maker's Den.
I think they're Eden Prairie.
Eden Prairie? Okay, thank you.
Yeah,
Eden Prairie Mall.
It is called Maker's Den, so you can find it that way.
Got it.
The tech is almost there for like a homemade respooling.
It only costs $10,000.
Yeah, it's getting down there. Like 2 or 3 years ago, it wasn't there, but now there are a couple different options that are a few $100s that have varying success rates, but we're almost there.
You can actually laser engrave PLA and ABS.
Oh, nice. So, yeah, we have about 19 minutes left. I think we should open it up for some questions. You've been patiently waiting. Yeah.
Yeah,
Oh.
I'm looking at.
And if you don't mind waiting for the microphone, please.
I'm looking at 3D printing more as a consumer than a hobbyist.
Yes.
And I'm looking into the possibilities of a circular sock knitting machine.
Oh.
If you buy the standard issue, what we had 20 years ago, they're $4,000. And I don't want to spend that.
No.
But I found a couple of companies online who will do them for $1,300. But what should I look for as the consumer for durability and things that will not snap after a possible fire?
I guess I can answer that from a costuming standpoint. I've used ABS because it's stronger than PLA and also can solvent very well with acetone, but at the same time, it kind of warps a little bit, and you need a heated build plate for that. So I've been kind of gravitating toward PETG a little more for the durability and reliability portion of that.
Did you say circular knitting machine? Is that what I heard?
It makes socks.
Socks. Yeah, I've totally seen people post. I've seen people post designs online where it's like all you need to supply is like the motor and the belt and the bolts and stuff. Yeah.
Yeah, I think I've seen someone 3D print that at the library.
Yeah.
Oh, nice.
Probably not PLA, and like Todd was saying, like ASA or ABS are very, very strong materials that are great, but you have to deal with some of the fumes that are noxious and not good for you, and the warping doesn't make it very easy. It's very temperamental. If you're looking for something that is easier and has that mechanical advantage.
We'll put tension on.
Yeah, right, exactly. You want something with it's called shear strength. That's the tensile. That's the type of strength. Is something you want something that isn't gonna snap or break when you put torque on it. And PETG is pretty good for that, and pretty cheap and pretty easy to print. It's a very good compromise material for projects like that. But the nice thing is, if you did use PLA or a cheaper material, and any part of that thing broke, you are fully and totally enabled to print a replacement part for yourself. So think about it in terms of opportunity cost, right? If PETG is a real hassle for you and you hate printing it, it's not very good for humidity. You have to dry out your filament ahead of time, otherwise it can get a little bit stringy. If you want to use PLA, knowing the mechanical disadvantages, you can be your own repair person and just print yourself off a new part without having to go to a store or anything, which is kind of great.
That is cool.
That's cool. Let's do the next question back here.
Hi. So I'm mostly interested in 3D printing for like cosplay purposes, like making sets of armor and whatnot. The size of the printer itself, can you do like full set of armor with a basic size printer, or would you need something more grandiose? I suppose that would be like amount of pieces it would come in, but like in your guys' experience, does that matter really, or can it be done with a smaller printer?
I printed a Loki helmet with the big horns on it. Printed it in several pieces. I sliced it up with a slicer to print different parts of the horns and all that. So you can do it with a fairly basic size. You don't need a huge printer for that. And I've seen some people print Mandalorian helmets with a bigger printer if they want to print the whole thing in one go. But it's easy enough to just print on a regular size printer and join it. Oh, there's somebody here.
Actually, yeah, you've been ready.
Sign.
Yeah, so a lot of the slicing programs will have a cut feature. So I've pretty much used Prusa Slicer extensively, and they'll have a cut feature that'll let you add like pins and stuff to join it back up. You'll still have to like fix it with post-processing and stuff to hide those lines. But yeah, you can cut up like a full-size helmet into a bunch of different pieces. Yeah.
Post-processing meaning like sanding?
Yeah, adding something and then removing stuff, basically. I bought a big printer as my first like major printer after the starter one, specifically because if I wanted to, I could just like print a Stormtrooper helmet in one piece on one printer, right? But like the bigger the volume, the price is pretty significantly more. So any of the larger printers get a lot more expensive. And I think if you're willing to invest the time in learning those post-processing skills, there are people that print very significant cosplay pieces on a Prusa or Bamboo Mini, which are the smaller ones, by just slicing it up into different pieces and pinning it or matching it back up with tabs, and then post-processing, because you can print it in the color you want as an end result, but ultimately you're probably going to want to end up adding stuff, sanding it down, and then painting it to get the end result you want for cosplay, generally. And so if you're already doing that, covering up those lines where you've joined the stuff up is not much more of a task. So it kind of depends on how much hassle you want to deal with and how much money you want to spend.
Why don't we go for the pink hashtag?
Do you have any experience with VariaShore or the foaming TPU, and any tips that you could share with those? Because they're very expensive, they're very beautiful, and just because they are expensive, if anybody has any thoughts on working with them.
You said the foaming TPU, right?
Correct. It's made by the same company as VariaShore. It's like working with EVA foam, but you can 3D print it.
Yeah. So the TPU is the flexible material that was discussed earlier, and this stuff, as you print it, it expands out, and because it's like cellular, it's like plastic with cellular space in between. That's basically what like EVA foam and other foams are. I have a friend that has printed some stuff with it. He printed himself like a mouse pad as a test print, and he said it was a expletive nightmare to work with, because not only are you worrying about like the humidity problems with TPU are way worse, because it's more porous, it absorbs way more humidity, it's so hygroscopic. But then also when you're printing it, he was like, none of the slicers I'm using for his like Prusa 3, I think, none of the profiles or anything he found online were really adequate at accommodating for how much it's going to expand as you print it. And so he's like, it's so expensive and it's such a hassle that I feel guilty trying to waste filament learning how to develop a profile to get it right, that he has like a half a spool just sitting at home that he's not using because it's just not, like, he's like, someone is going to come along with a profile that prints it well any day now. And once someone else figures that out for his printer, he's going to use it.
Next question?
TPU, definitely get a filament dryer.
Yes.
it's actively trying to absorb humidity, and then when you run it through a nozzle that is well above the boiling point, all of that humidity is going to turn into steam and make it look very pockmarked on your print. So yeah, heat up your TPU, keep it dry. Yeah.
Right. Next question.
I think blue circle.
Yeah,
It's my
for
fault.
someone that's totally new to this, can you explain what a slicer is?
Oh, yes.
Loading something into a slicer, what does that mean?
Yeah, we don't want to feel that.
Yeah, Slicer is a software that interfaces with your 3D printer. So I like to think it's called a slicer because of the layers. So you're sending, this is prints layer by layer, you're sending each layer to the 3D printer. And we use Cura. The software is usually free, so if you're using somebody else's 3D printer, like a Makerspace or something, I always recommend to download the slicer so you can see if there's any errors, if it looks weird, what supports you're gonna need, and especially how long it's gonna take. And with our slicers, you can change the size, you can multiply, rotate, but other than that, you can't edit.
It is
Yellow circle.
a program that takes the 3D file and turns it into a set of instructions for your printer.
Yeah, here it is on the screen.
And so that's where all your settings are, like the speed that it moves, the temperature that it gets up to, what kind of patterns it's using to fill in all the inside spaces. You set all those settings in your slicer, and so you do a lot of your tinkering there and not on the printer. But what it ends up out exporting is like usually like a G code, it's called, or a BG code, or Bamboo has something that's proprietary that's similar. And all that is like Cartesian coordinates, where it's like move to X this and Z that, move to here, move to here. And then also like while it's moving, it's like move the gear forward to excrete this much plastic at this rate during these movements. And so like if you open up those files, it's literally just like that old turtle program for Mac. It's just telling like forward this much, backward this much.
Yeah, so right here is the G code that it's reading.
That's G code. Yeah, it's like a translator. It takes the 3D file and turns it into instructions for your printer.
Do you need that alongside something like Blender then?
Yes.
Okay.
Yeah.
So if you're going to do any 3D printing, you need a slicer. Yeah.
Yeah, I use Simplify 3D as my slicer. It's commercial software, you have to pay for it, but it's got more options and slices a lot faster than some of the open source stuff.
I think more or less almost all of the slicers and software that are out there are all kind of based on the same open source slicers eventually, when you go far enough back, right? So like Orca and Cura and Prusa are all kind of using the same code base and the same features, more or less, and accomplishing the same task, with presenting you that information in a different way for different printers.
Next question. We have a few minutes left.
I started off with an easy printer, like one of those cheap Bamboo or cheap,
Did you hold the mic a little closer?
cheap Micro Center ones, and after trying to figure out how to do a manual bed leveling, I said, no more, this is not for me. And bought a K1, and had nothing but issues with that thing.
Oh no.
The firmware stopped in the middle and then went to Chinese.
Oh.
And I had to figure out how to speak Chinese for a while.
How nice of it.
And then a friend of mine gave me his P1S, and I'm like, oh yeah, this works, man. I just like didn't have to touch anything, it worked right away. And I just swapped the file and G codes around between this and the P1S, and now I have 5 Bamboos. And they just work like a dream. I printed a whole Phase 2 Stormtrooper helmet yesterday.
Oh, nice. Yesterday.
I think like, I don't know if you all will agree with me or not on this, but I feel like the 2 most fiddly things that people deal with or spend the most time with on average, and depending on the type of printer you have, they're gonna complain most about belt tension and leveling. And leveling is such a misnomer because you're not actually leveling the bed, you're evening it out to the perspective of the nozzle, and a lot of modern printers are starting to compensate for that. Prusa uses load cell detection, where it actually touches the bed and measures the magnetic or capacitive response to measure out where it is, and it makes a little grid in its mind to know that this little part is this many point whatever millimeters above this little part of your bed. And I know bamboo printers have LiDAR in them, laser radar, but they don't use it for bed leveling yet. They might someday, but right now it's just used for like spaghetti detection, which sounds more delicious than it is.
It could be this tiniest little bit of filament on your nozzle, just the easiest, and the bed won't be level.
Right. And spaghetti is when
As soon as it doesn't.
when it's extruding material and there's nothing to stick to, and so it just makes this big heap of spaghetti. Next question, please.
Yeah, I'm in the market for getting a new 3D printer, and I'm wondering if it's worth it to get an enclosed one versus an open, and what are your opinions on that?
Yeah.
So it depends on a lot of things. One, do you need to print stuff that needs a higher enclosure temperature? So like the more high-end filaments will need the enclosure to stay above like 60 degrees C or something like that. If you're just printing PLA, they don't want you to be enclosed actually. Yeah.
Oh, I think over here next.
If you have a lot of kids running around that might poke a printer while it's running, maybe get some doors for it.
Right.
Or cats.
Yes. That has tried to jump into my printer many times.
If your printer is going to be right next to an air vent, you'll want to block that somehow. For most things nowadays, if you're just printing PLA or PETG or even TPU, you don't need an enclosed printer. I think possibly my favorite printer is the Prusa Mark IV, Mark IV-S. It just works, and it's not enclosed, but yeah.
Yeah, ABS benefits a lot from having an enclosed enclosure. So the flush forge creator I got is open, but I got some acrylic pieces that Axeman surplus and put screws in there, and I can put them onto the sides of the printer whenever I need to print ABS.
There are a lot of designs out there for, the like $10 to $15 lac table at IKEA. There are a lot of people who have turned those into enclosures. Where any printer that's like a Mark IV or a mini type printer will fit in there just fine, and they have instructions where you just print off these parts and buy these bolts and boom, you have an enclosure. That said, if you're not worried about venting your fumes or anything like that, and you just need an enclosure, there are people out there who are like, yeah, I print ABS in a cardboard box and I don't have any problems. And literally all they do is like fire up their printer and put a big cardboard box over it and leave the room. And that works great.
Okay. I think
I've had 50 happen. Yeah. That'll do it.
so. I think we have time for one more question.
For someone that's totally brand new, could you theoretically start with resin, or should you cut your teeth on MDF?
I don't see why not.
Depends on what you want to print.
Yeah,
If you want to print
you definitely can just buy a resin printer. My buddy's sitting over there, he just has a resin printer. The main thing is do everything you can to not get the resin to touch your skin.
Yes.
Try not to breathe in the fumes.
Don't rinse it in the sink, because that goes into our water supply.
Yeah.
Feed it after midnight.
Right.
Yeah. Invest in isopropyl alcohol, figure out how to dispose of it properly. There's definitely hoops you need to jump through, but they are not too far to jump through.
All right, I think we got one more.
Got two software questions, actually.
Let's fill them.
First one, are all these file formats standardized, or is there 42 different ways of
More often than not.
think generally the two that you're going to see a lot are going to be STL and
3MF.
3MF.
So up on the screen, I have Crucial Slicer, the import, STL, 3MF, step file, OBJ, AMF. STL is kind of like the standard 3D
If
shape.
there is more than one file format, the software generally recognizes it.
Oh yeah.
Okay, so
Yeah.
part two. Slicer is the issue here, and I'm speaking from ignorance.
Okay.
Okay, someone complained to me that the problem with 3D printing is it's like Minecraft. Little notches back and forth, back and forth. It doesn't know how to do a smooth curve.
Oh yeah.
Oh yeah.
Putting a lot of sandpaper in there after the fact. Is there any forecasts, any promises, any outlook?
Yeah.
The slicer software might change to curves instead of.
One of the coolest things about 3D printing as a hobby, in my opinion, is that the printers I have today will be able to do more better without me spending a single penny to buy more parts or to upgrade them just due to software upgrades. People are, to this day, figuring out ways to print things to make them stronger by staggering lines like Lego bricks, printing at different heights in the middle to make things stronger, or printing, the algorithms that go into printing curved lines are getting better and better and better. And those instructions that go to the printers, even if the printer isn't mechanically better, the instructions that are being issued in a better way to fit that printer. And so they're improving, right? And there are things you can do like printing a curve this way, where it's going to need to make steps every way, is always going to be a little more jagged. But if you turn it sideways and it's printing that curve this way by moving in a circle, that's going to be super smooth. So like sometimes it's not just a matter of the printer, sometimes it's a matter of the angle that you have it set in while you're printing it.
Yeah, just the rotation can make a lot of difference, where you lay it flat or stand it up.
Right, and we are actually at time, so we got to wrap it up. But if you have any other questions, I'm sure we'd be willing to field those. But thank you so much for coming. I hope you learned some stuff.
I still have some 3D printed badge ribbons. If you want a 3D printed badge ribbon, please take one. I printed too many.
Add to the discussion by commenting on this video.